Alright, welcome back. Our tutorial game, in progress at the moment, has an interesting bug problem. We've got our map, we've got 2 rooms. If we go into the next room, we scroll but the map flickers back. Well, that's a problem. We can take this else out and hack it that way. Of course, now we don't know that we can go back. We have the opposite problem, right? We can say else if x less than 0, then map equals 0, and put the player back at 127. Else if is 1 word, there we go. And it kind of works at this moment. Really, the way we've done our map, you can see that the player doesn't completely come on because, again, it draws at the top. We want to draw them at 120 when we come back. That will make it look like, because it looks like when you're standing here, you're in the column. Now you want to be in the column. Now you want to be in the column. You're in the column. You're in the column, right? Here it looks like you're leaving the column, so it makes sense to look like you're leaving the column there. And so, in fact, once you go all the way through this column, you shouldn't start in this column, right? Looks like you got thrown back. So let's go ahead and start it at 8. Sort of clean up some of these visual artifacts. And the reason I'm doing this is you can quickly see how this can get kind of complicated, and we'd like to simplify this out. So there's another function we can use, and that is called the camera. What the camera does is, instead of changing the mx and the my, okay, we're going to leave those alone, and we're going to have a camera x and a camera y. And before we do any of our map code, before we do any drawing code, we're going to call camera and pass in our camera x and our camera y. Okay, let's go to the wiki page for the camera. The camera is a bit tricky to get started with. Okay, setting a camera offset causes all subsequent draw operations to have the offset subtracted from their x and y coordinate. Camera sets the origin point by default is 0, 0. A little unintuitive. So you might expect camera 64, 64 to put the camera origin in the middle of the screen. You would actually use negative 64, negative 64. So that to move the screen, that is middle is front of the camera. So basically what the camera is doing is passing in a value that's going to adjust all the other draw and map calls are going to be basically subtracted by the amount that we pass in. Okay, so let's do some basic math. Let's figure this out real quick. This screen, the new tile here, starts at, oops, give me my draw tool, there we go. It starts at 16, 0, 0. Well, 0, 0 tiles is going to be 0, 0. But 16 is in tiles, is in map units. So we need to convert 16 to screen units. That's times 8. You know what 16 times 8 is? It's 128. Remember the screen is 128 by 128? So This is just an easy way. No, that's wrong. This is wrong. This is bad math. I'm sorry. I know the answer that I wanted to get to, and didn't pay attention to what I typed. No, I'm sorry. It is correct what I typed, and it's going to work for us. We don't have to worry about offsets in this case. Basically, 128, the reason I got confused there by my instinct, is the new 0 for the next screen. When we go to the next screen, we want 128 to equal 0. In other words, we want to subtract 128 from everything we do and shift that over. That's what the camera does. So, we come over to code, and we say if the player is X, camera X equals 128. And if the camera is less than 127, CX equals 0. Now everything is just working for us. Okay, so I'm going to go back over this in detail because you can see that this is going to be the way that you're going to move maps and screens around, but it's a bit to understand, right? What I'm doing when I'm setting this 128 is I'm telling, like we just had typed there a second, we moved the player. When the player got above that, we set it back to 0. Well, now I'm saying just take whatever the player is and subtract 128 from it and draw the player there. Same with the map. Whatever you were going to draw the map at, shift it by 128. Okay? So the player gets subtracted, but you kind of feel like, wait, isn't the map being added? Oh, you're not completely wrong there. You go to the map, and you dig down into, they're not a map with the camera section. I apologize. I thought that it explained the map, the way the map works. But the map is being subtracted. So what's really happening here is, again, magic tool time. Here's our screen. Okay. And then if you think about our map, it's really 2 screens, correct? So let's go to blue. Oh, blue's going to be hard to see. Let's go to red. So our map is actually 2 screens here, right? It's actually that far off. We're just seeing this window. Okay. If we subtract 128, fraction's going to move it that way. Then what's going to happen, we'll use yellow to show the new state of the map, is the map's going to move that direction, and we're going to see the other window. Okay? So that's how it is subtracting with the map. It is an area of coding that is very simple in code. The code very easy. We're not doing a whole lot here, right? But can take a bit to grasp conceptually. But once you get it, it's going to save a lot of time, make things a lot easier for moving around the screen. The other way that we might want to do this is make the camera position offset from the player. So let's say if the camera is CX equals X minus 60. Now we have a scrolling map. It goes out of bounds, and I didn't do Y because we're not doing up and down. We don't have any maps drawn for that, so let's fix that at the moment. Go ahead and go over to our map here, and we'll add into the second room. We'll add a room down. So I'm going to select this room, copy, go to stamp tool, paste it. Oh. Paste it. It is lined up. I'm going to zoom in real quick. Hold on. There we go. Get that tool off. Come down here. Close that gap in. Come down here. We will, let's make 2 gaps. Make it interesting. Why not? There we go. Got 2 gaps going down into this room. Run it. Of course, we didn't implement the up and down yet, right? Go back. There we go. And to save us some getting crazy bits here, I'm gonna stamp a room there. So we have a nice even square for the demo. We'll save non-square map editing techniques a later video. Okay. So we have like a very gauntlet-like map level. So we need to fix this camera up a bit. And to do that, we need to think about the logic of moving around the screen. So right now, we could say if x greater than 60, then and if y greater than 60, now we can move up in here and it won't scroll above 60 and 60. And we can go down, we can go left and right and scroll around and it will work okay. Okay. We actually need and equal then. Because we want it to be 60. 60 is okay. 60 is where we start. Right? That smooths it up. Okay, and then we can extend this so that it doesn't go beyond well, actually, this moves the camera. So x equals 60. If x is less than or equal to 60 and x is less than or equal to, oh, we got to figure out what that is, don't we? So we come over to here. That is tile 31. But really, we don't want tile 32. Okay, we don't want this border showing here, right? So it's 32 and 32 in each direction. So that's going to be 256 if you work the math out. So we're going to do 255. Let's just test that. Oh no. I've done it bad. Oh, but we have to take back the 60 here, right? Because it's offset by 60. So we move that one by 60. So this is actually going to be 255. You just type it in. You don't actually have to do all the math in your head or work it on a scratch page. You can just let the computers do it. They will do it. Okay, we're off by a tile. So, say 247. Does that work? Are we one tile short? We are. Not one tile, one pixel. Okay, we worked out that edge, and it's going to be the same down here. We can't break that edge. We can't break that edge. And we can't break that edge. So we've confined our camera zone, but the player can still move anywhere. That's fine. But there is another way we can do this. And that is thinking about how we want to move the player around conceptually. This is very specific to this top-down view. What if we were a side scroller and we wanted to sort of have this zone in the middle where let me just run this here. We want to have this zone in the middle where the player doesn't move, right? So like in Mario, you can go back and forth a little bit and the camera doesn't move until you get to this direction or that direction. We can think about this in all directions as like a box, okay? So this box, the player needs to stay inside. And if the player tries to go outside the box, then the player pushes the box in the direction they tried. So if the player's over here, instead of letting them go outside the box, they push the box, which scrolls the whole screen. They can then go back, which, as long as they're inside the box, doesn't move the screen. But if they then bump up against this wall, we then push the screen in that direction. So, to make this easier, let's set up our box, okay? And I've been typing CX and CY and MX and all of these different things to hold this. But for box, let's use a more advanced feature of Lua. So I'm going to open curly brackets and close curly brackets. And then I can do things like the box.x equals, let's say, 32. Box.y equals 32. The box, I could do this by height or width, or I can do this by an x2 and a y2 value. I'm going to go with the x2 and the y2 value. So if 32 by 32, 64, let's go to, let me pop up my calculator real quick. Let's see, what do I want? I don't want 64 by 64 to be the center, do I? Because the sprite needs to be centered at 66. But for the moment, let's just start with that. You know what? Let's just keep it simple. And let's add 32 and subtract 32 in both directions. Okay. So by doing these curly brackets, box equals curly brackets, I can now do this weird dot thing. I can say dot x, dot y. And this dot X is not going to be the same X as this X. So in practice, it's better to always set up your variables into little containers, little boxes, if you will, like this. So down here, after we draw everything, I'm going to add this little if true, then end. And this will always run. There's a command in our graphics called rect here. And it takes in an X and a Y and an X and a Y and draws a rectangle at that color. And I'm kind of partial to the green I draw on the screen with, so let's color 11. So I can do rect box.x, box.y, box.x2. You can also, see how I'm kind of about to go off screen? You can hit enter and line these up this way. That's completely okay. So put things on multiple lines. And then color 11. So now we got the box that I want to push, right? And now we're going to confine the player within that box. So the player cannot now move outside of the box. Let's go with remove player. Here at the bottom. If X is greater than box X, then X equals box X. Else if X is less than, hold on, I did this backwards. If the X is smaller than the box X, meaning they moved out to the left, then put them back in the box. And then if they are bigger than the box X2 score, they moved out the right of the box, then X is going to equal box.x2. Now, I'm going to run this. Player should not be able to get outside this box to the left or the right. Now, because the player is drawn from that top corner, it's not quite even, right? Because they're trapped by that top corner. So really, what we need to do is bring that line back, the width of the player sprite, back 8 pixels, basically. But before we leave, let's make it work for the top and the bottom. All we have to do is change these to Y's. Can't get out the top. Overextends on the bottom. Okay. So to even that box up, by the way that it moves, because it only tracks that top pixel, this one here, we can now take back the width of the sprite, which is 8. So instead of 96, 96, it's going to be 88. You cannot time travel because you cannot go beyond 8. Okay, now the player now is never going to really move outside of this box. And we're never going to move this box, okay? We don't want to actually move the box. So what we want to do here, I'm going to take out all of our camera code for the moment. We want the camera to move when that happens. But we don't want the player to move. So the player is going to stay inside the box, but we need to adjust the camera as long as the player is attempting to move that direction. What am I saying here? What I'm saying is, if the player is on the left edge of the box, or trying to move to the left, or trying to move this direction, then we're going to take the camera and we're going to subtract from it. And here I will use minus equals, say 1 pixel. And if they're trying to go out the other direction, we're going to move the camera plus equals 1. Same here. If they're trying to move off the top, then the camera minus equals 1. On the Y, notice I'm changed to the Y here. And if they're going out the bottom, then the camera Y plus equals 1. So the camera, oops, I typed Y down here, and X. So X's are all together, Y's are all together. So my camera is going up. My player doesn't actually get outside the box, does he? Now if I run him to the other wall of the box, off screen, didn't see me do it, he pushes the camera that direction. Push it. This is what we're talking about. The player is going to go to the edges and push it. But of course now the player is staying in the same place. We could now offset the box by the camera and offset the player by it and move it all together as one unit and just slide it all around the screen. Or we can make it easier on ourselves. And before we draw the player, we could set the camera back to the start. So now it appears like we are dragging this box around the screen, but in truth, the box is never moving. We are never leaving the screen. We are simply adjusting the camera, drawing the map to the new camera position, but then setting it back before we get there. What's the advantage of doing this over what we were doing before? Well, you never have to worry about where the edge of the screen is. Okay, even though we're over here right now, this here is always 0, 0. This here is always 127, 127. You can always know where everything is at. So for example, we come down here, we're going to draw the score, right? So let's draw a rect filled, right? I'm looking over here, rect fill. We just know if we want to span the top of the screen and come down 16 pixels, so we're going to go over 127, and we're going to come down 16, well 15, we count the first pixel, and let's clear this to be, what's a nice color here? Let's go with this green, okay, color 3. To create an area for the score, we never have to worry about the player being able to move into that area, or the score having to be recalculated from where we're on. We can draw fixed elements like life bars and power-ups and level and all that thing on here without ever having to move that area of the screen. Right? It's always going to say these numbers. They'll never change, and it can make life a whole lot easier. One problem, though, is that the camera can move into positions the camera should be able to move to. So, after we have adjusted the camera's X and Y, we can just come down here and we can say if camera X is less than 0, then X equals 0. Else if camera X is greater than, what was the one, did we erase that? I think we erased it. We had figured that out to be 256 minus 60. Was that the correct edge? We'll test it again. Here we go. We'll scroll the camera this direction. Nope, we're off. Off by quite a bit. Oh, it's a whole screen back, right? It's a whole screen. It's not just the offset of the center. We want the camera not to go beyond this square, right? That's the square where the camera has to stop, which is 16. That's actually going to be let's see if this works. And it does. So we need to do the same here for the Y. Move the camera and then check the camera. And here we go. Can't go lower. Make sure our can't go less than 0, 0. And just because it's throwing off, perspectives here, we can hide that rectangle by setting this to false. That was the reason I typed if true. You can put your debug stuff in this little if true, and then just change it to if false, and turn off debugging. Right? And then just see what it looks like. And it's got a, it may not be the mode that you want for this game, but notice that now that we have that box, we don't move the screen around unless we actually get to one of those now invisible boundaries to move our screen around. So that is moving around with the camera. We got a bit of code, but it's okay, I think, at the moment. We don't need to worry too much. It's not messing up this. What I can do, however, is since this box is really only related to the player's movement, I can go ahead and take that out of here. And the CX and the CY. We don't need MXNY because we're not using it anywhere. Come over to the player. Set our box, set our CX equals 0. CY equals 0. I typed a comma there, don't know why. Back here, get rid of those. Don't need them. Back a little bit. So here we knit the player, move the player, and then when we draw, all of this function here is really in drawing the map. Let's just add a new one here. And clean up our code by taking all of that out. And say, we set the camera position. We swap the transparency. We draw our map. I'll give that another line. We put the transparency back to normal, and we put the camera back to normal when we're done. And this down here is a debug statement. Let's not worry about that. And what we need to do is draw a map and player. And everything works. All right. So that's been moving around the map with the camera. Next video, we'll look at actually smashing into things. Collision.